Hello there reason people, PoohBear here and welcome to my channel, and today we're going to be making ourselves a counter version 2. I should have really done this video straight after doing the last video because I noticed there was a little bug that when you start to increase your buffer sizes above 64. So we're going to have a look at building ourselves a very quick counter. So you might want to have a look at the other video if you want a lot more details, and we'll actually have a look at the bug and we'll also look at my workaround of that particular bug. So what we're going to need really to build this is we're going to, I'm going to use the Hamu as a source so I can actually drive some CV data in. Obviously this could be an LFO, this could be anything you wanted to, I'm just having to be using that. I am going to need myself a dual CV source, so we'll grab that. I'm going to need myself a merge splitter, and I'm also going to grab myself a CVA7 and another dual, because at the end of the day you're going to want to see some results coming out of this and not just take my word for it that it's all working really at the end of the day. So let's quickly wire this up. Well, the first thing we're going to wire up is the merge splitter. So I'm going to put the merge into the split. I'm going to take one of them out and put it around, and so I've now created myself a CV feedback loop, and that's going to be going on and around and around and around and around and around. Now what we want to do is we want to inject a bit of data from here into this loop, which is going into a round circle. So what I'm going to do over here is grab button number 1, and I'm actually going to put that into what's called the latch. Can I zoom in here? Yes, of course I can. So we go. So we're going into what's known as the latch on this device. And so what I can do with this particular device is, this is the latch data. So under advanced, these are your latch types. I'm going to go for a rising edge, which basically means when it's changing anything above 0, it changes the value, it's actually going to cause a signal, or it's going to cause a latch. And in my particular case, I'm going to then take that latch out, and that's a full volt. It's sending out a full volt. So I'm actually going to push it back into itself and scale it down. That's all I'm doing here. It's just purely scaling this down. So I'm going to take this down all the way down to 0 because it's the easiest way of doing it. And then I'm going to click and hold. So I'm holding my mouse down now, and you can see when I hold my mouse down, you get these arrows above and below it, these little tiny arrows. I'm just going to move it up one. So when I let go, it goes back to 0 because that's the actual output voltage. When I hold my mouse down, my mouse is now down, this is like the value I'm going to be offsetting it, or whatever I'm doing with it. So that's the true value that's going out, and this is more like an offset. So then what I can do is take this value and I'm going to inject it into this feedback loop. So I could say to you now quite simply, whenever I now push this button, I am adding 1 onto my loop. You can see the little lights are flashing, but you can't see anything. So let's actually quickly take a feed out of this splitter and so put it into that one so we can see it. And I'm actually going to put a feed into this CVA as well, just for the time being. So now, and let's put this onto raw. You're going to hear me refer to integer numbers here of like 1, 2, 3, 4, but really I'm talking about 0.0003, but I don't want to keep saying to you 0.0004, 0.005, so 3, 4, 5. So whenever I push this button over here, you're going to see this counter go up here. So push, push, push. So we've got ourselves a counter working. And this is, you can see this blipping on because that's the latch going. The latch is sending its data through, and then it's allowing that to come through. Quite straightforward. Now when I hit this little reset button here on the analyzer, you would notice that this value will go to, well, this is 110. It's because it's got one extra decimal place this one goes to. So really that's like R11, and you can see that. So they're both the same. So it's saying that the lowest value, which is going through this device at the moment, is 0.0011, and the maximum is 0.0011, so 11. And obviously if we then take our counter and go up by 1, the minimum stays down, and obviously the maximum goes up until I hit the reset again, and then it's both the same. This is an important bit because this is part of the bug, what you're going to actually, you can see for yourselves. So what I'm actually going to do now is go off this side of the screen and grab on my preferences. And at the moment, as you can see, I've got render audio to buffer size turned off. So that means I'm using the 64 buffer size. So I'm just going to quickly click that on. So now I'm going to be using the proper buffer size now. So now when I click this, you can start to see this, look, it's jumping between two things. And when I hit this particular reset, remember before it would always go to, like, say the maximum or whatever it happens to be. Whoops, zoomed into the wrong place there. You can see it's got two values. So let's actually increase this even more, make this an even bigger number. And you can see it's all flashing away there. it's all going a little bit doolally. So now if we hit reset, you can see 12 and 26. So what's actually happening, if I scroll up very slowly, is we've got, and I'm just going to forget the voltage, what's actually happening now. We'll keep it nice and simple. Let's have a 1 volt and a 0 volt. I've got, say, at the moment, 0 volts going through, coming around. Can I hit K and maybe get rid of some of these wires? Yeah. So let's say we've got a 0 volt going through this merge into this split, from this split, still 0 volts, coming back 0 volts. I then inject 1 volt coming down this wire here. So we've now got 1 volt going along here. Well, we've still got a 0 volt coming down this wire here. And then what happens is we've now got a 0 volt coming across the top, and we've got this 1 volt coming along the bottom. So the 1 volt comes up, but the 0 volts come, and that's what's happening, and that's why we're seeing this flip between two different signals. 1, 2, 1, 2. As I say, when it's at a block size of 64, you do not get this. So obviously Reason was designed to work, well, it was default was a 64 buffer size. So obviously when they, 10.3, yeah, it was 10.3, where they allowed us to use the actual audio buffer size. This is one of the fallouts from it, you know. CV was sort of built around that sort of buffer size, and now we obviously can have larger ones. So yeah, this is one of the knock-on effects or bugs you can experience. We can actually resolve this very, very, very simply. So what I'm actually going to do is I'm just going to dewire my CVA7, and I'm going to disconnect from a merge to my merge A. So okay, so we've just broken, we've got no feedback loop at all. I'm going to take this merge and put it into the CV in on the CVA7, and I'm going to take the max and put that into the split. And I think of this as my valve. So you can think of yourself, you've got a big tube filled with water, and there's an air bubble in it, and that's our air bubble following around. As the water goes around, the air bubble is getting pushed around, and this is going to be our valve to release that air out. So now what's going to happen is we've got our 0 going through the systems, coming down here, 0 is coming out of here, through into here, and 0 is coming down here. So let's actually start from this point here and say, right, we've now put a 1 down into here, and we've still got a 0 on this point here. So a 0 is going off down, sorry, 0 has gone off down this point here, and now our 1's come along. 0 is going to come out and still loop round the system, but our 1's are now going to come into this system from here and then loop back round. But this time when our 0 comes back down, because we've now got a 1 going through, the CVA7 is going to look at that 0, as I said, like our valve, and go, well, actually, I've now got a 1 in my system, so I'm now going to squeeze that air out of my tube, and I'm going to just push a 1 out, because a 0 is smaller than a 1, and I'm sending out the max voltage, which has been through me. So now we've got a 1 cleanly moving through this system. And we can obviously come over here and hit our button, and you can see it's now going up nice and cleanly. It's not jumping backs and forwards. Also, when I hit this reset button, oh, I can't hit this reset button. I'll tell you why, because this is now part of the actual counter loop, and if you hit reset this, it's going to actually reset everything back to 0. So this is how you reset things to 0. And I'll talk about that a little bit more in a second. So let me just quickly grab this, hold down control and make a copy of it. And I'm going to take a feed and actually monitor this now. And what we're going to do is just hit this a few times. So we've got ourselves a counter. You can see we've got a 1 here. So we're going to hit a reset here, and you can see it's the same figure. So it thinks that is the smallest one, which is correct. So what I'm saying is what we're seeing is correct. And it'll stay, because that was the smallest figure it had until we hit reset again, which is brilliant. This reset, the only way you can reset this is obviously by pressing this button, or you have to put this into a combinator, and then you can use the CV signal going into the combinator, and you can route it up to hit reset, because there's no reset on the back of this device. A little bit of a shame that, because it would have been well handy. But saying that, I do know Pongosoft has released the source code for these devices, and you know, probably could put in a request or do something, because it wouldn't break anything to put a CV in the back to say, hey, we want to hit that reset. So that would be quite a handy one. But don't think just because we're also just got ourselves a simple counter up, and it's only going to ever count up, we can obviously change this and offset this particular counter to get ourselves other signals. And what I basically mean by that is, let me just make a copy of this a few times. And what would we want to do? I'm just going to take this split and put it into this splitter, and then I can take this signal 1, 2, so it's going to be the same signal which are going in. So we've got the same signals going in. Let's make sure they're still working. So here we go, they're all working. I might invert this one, so this is now a minus. So as we're hitting the button, it's going down in a minus figure. But what I'm actually going to do is I'm going to hit this onto a plus. And the only reason I'm going to, like the top one, you don't need to do this. I just thought I'd do it because then that way all we have to do is focus what's going on over this side and not worry about what's happening on this particular side. So I'm going to put that to a 0. I'm going to put this to, let's grab this right down. So again, let's grab this nice and small. Whoops. Oh, I should just put it to a 0 and then let's move this up. So yeah, let's move that to 30. So you can see, I click on 30 and my mouse is down. So I've got my little arrows up and above. And as soon as I let go, it jumps down to 26 because 30 minus 4 is 26. Yeah, and on this bottom one we could offset this. I don't know, let's go the opposite way. Let's put this into a minus 30. Bit of a boring one, but so now when I hit my button to count up, you can see we've got ourselves a counter counting down, we've got ourselves a counter counting up, and we've also got another one which is counting down but in a negative range going up. So from a simple up counter, you can manipulate it very, very quickly to do lots of different things. And what I'd actually use the output from this type of counter would be to control, more often than not, be something like an A-B switch. If I was to grab that A-B switch and to say, okay, I'm going to take this feed from here and control here, flip it around. As you can see, we're on A at the moment, and if I just quickly, he says, I'm going to quickly keep hitting this button. And as soon as this starts to go into a non-negative number, which would be 0 and above, you'd see the A flips to B. So that's the sort of logic I would use. And there is actually a rack extension in the shop called Now, which is a basic counter. But what would happen is once you've actually got to this point and then you fire off another trigger into it, it will automatically reset the counter, which is quite, works in a lot of cases. But in my particular, the reason I came up with this particular counter and I went down the route of building this counter is I wanted to do something even though I'd reached my value, i.e. so I've now changed the logic of this switch so I can actually do something different. And it doesn't matter if I've still got this counter going, I'm now still on my B logic. And then when I'm actually ready, I could reset it and then I'm back on my A logic. So I wanted to have control of when I hit my reset after I hit a particular threshold. That's really what we're talking about. We've got a counter, hit a threshold, we're going to do something, and when I'm ready, not when it decides when I'm ready, I can then reset the counter. And that works very well. And that's really what this counter is all about, is hitting thresholds, and then we can go off and do some other logic. As I said, the input could be anything you want. I mean, at the end of the day, I'm going to take this cable here and I'm going to plug it into the gate. As you noticed, I don't know if you did notice, when I unplugged that, it all went mental and it was counting up very fast. So I'm just going to hit reset. And now what I'm actually going to do is I'm going to play some notes on my keyboard. So there we go, I'm playing some notes on my keyboard. I know you can't hear it because obviously I haven't got any instruments, but more to the point, I have just now played 39 notes on my keyboard. I could say, would I play my 40th note? Obviously I could do something with my switch, and that switch could turn the filter right on, filter off, it could turn arpeggiator on, it could change the pattern of an arpeggiator, it could do anything, so, and then I could reset and count up another 40 notes, or I could set it so it carries on until I've done whatever I've wanted to do, and then at this point I might just say, no, I want you to reset back to the 0, and then we start counting again. But more to the point is I'm using my keyboard, playing the keys, and I'm counting my notes. So you could use all sorts of things to trigger this. So it's just, you never know, one day you're after something and this might be the kind of solution you might end up going for. So, yeah, starting to waffle as usual, a simple counter. having to use the AV switch and using the max coming out of that to get around the loop if you're going to use obviously a buffer size bigger than 64. And as I say, this will have to go into a combinator to use the reset, and that's about it really. So thanks for watching, and bye for now.